Very good morning, one and all. My name is T. Rajita, lecturer in ECE, Government Polytechnic, Mamnar. So I am dealing with third semester. In that, I am taking the network analysis subject. So now I am going to discuss the topic identification of nodes and nodal voltage equations. So what is node? Already we discussed in the before classes. What is node? A node is a junction of a point where two or more branches are connected. What is principal node? A junction point of three or more branches are connected is called as principal node. What is the reference node? A reference node is principal node with which other node voltages are measured. So on completion of this period, you would be able to identify nodes in a given network. And find the number of node voltage equations required to solve a given network. Write node voltage equations and to arrange them in matrix form to solve for node voltages. So here one circuit is given. In this, first we have to identify the nodes. See here the nodes, two branches are connected to node 1. Here only two branches are connected. At node 2 there is three branches are connected and it is called principal node. And at node 3 there is three branches are connected and it is also called as principal node. At 4 there is two branches and there is a normal node, and at 5 there is four branches are connected and that is called principal node, and it is also called as a reference node. So here in this circuit there is three principal nodes. So the number of voltage equations are 2. So in this way we have to identify the principal nodes. See here, this node, the four branches are connected. So now I am taking another example. See here. In this, how many nodes are there? Just try for this. So how many principal nodes does this circuit have? That is the question. 5. 5 principal nodes are there. How? See here. At principal node 1, there is a three branches are connected. At principal node 2, there is three branches are connected. At principal node, there is a four branches are connected. At principal node 4, there is a three branches are connected. At principal node 5, four branches are connected. So in this, all nodes are principal nodes because at every node there is a more than two branches, that is three branches are connected or four branches are connected. So in this circuit, all 5 are principal nodes. So how many number of voltage equations can be done? In any network, the principal nodes, first we have to find out the principal nodes. and number of voltage equations is equal to n minus 1. N is the number of principal nodes. So the number of equations is nothing but just find out the number of nodes and minus 1. See, already we studied this nodes. There are 5 nodes are there. How many equations nodal voltage equations? 4 nodal voltage equations are required. 5 minus 1. Procedure to write the voltage equations. So identify all principal nodes in a given circuit and choose one of the node as reference node. Choosing reference node is arbitrary. Any node can be chosen as a reference. But it is convenient to select the reference node with more number of branches connected to it. So more number of branches are connected means naturally it may be ground. So now identify all the nodes with numbers or names like V1, V2, V3, etc. And reference node is V reference. Like that we have to name all the nodes. To write nodal voltage equations at a particular node, assume all currents leaving the node except the current from the given current source. By applying KCL, means Kirchhoff's current law, at each node, write the nodal voltage equations for each node in terms of V1, V2, V3, etc. Arrange them in matrix form and solve using Cramer's rule. This is the procedure to solve the network. Let us see how to write node voltage equations. See, identify all principal nodes. In this circuit, there is 3 principal nodes. And choose one of the node as reference node. And choosing reference node is arbitrary, but it is convenient to select the reference node with more number of branches connected to it. So that is the reference node and principal nodes. Name the principal nodes. What are the nodes? We are identifying the nodes is V1 and V2 and V reference. V reference is the principal node, that is the reference node. Now let us see how to write KCL at each node. So what is KCL? KCL is the Kirchhoff's current law. The algebraic sum of currents at the node is or a junction is equal to 0. So that we can write the currents at the node is equal to 0. So suppose the current, by considering at V1, the current at node V1 is equal to 0 means V1 minus Vs by R1 and V1 minus V reference by R2 and V1 minus V2 by R3 is equal to 0. Because at node there are 3 currents, the current I1, I2, I3. So the current I1 is equal to V1 minus Vs by R1 plus V1 minus V reference by R2 and V1 minus V2 by R3 is equal to 0. That is the first node. Here the number of equations are 2 because 3 nodes are there. 3 minus 1 is equal to 2 equations are there. What are the equations? V1 and V2 with reference to. So the first nodal equation is V1 minus Vs by R1 plus V1 minus V reference by R2 and V1 minus V2 by R3. Similarly, the second nodal equation is V2 minus V1 and V2 second nodal equation at V is V2 minus V1 by R3 plus V2 minus V reference by R4 plus V2 minus V reference by R5 plus R6. These are the two node equations. See here. To write KCL at node 1, assume all currents leaving the node. See here. This is the equation. So currents leaving means V1 minus Vs by R1. V1 minus V reference by R2. V1 minus V2 by R3. V1 minus. So to write node voltage equation at a particular node, assume all currents leaving node except the current from the given current source. So these are the equation. This is the first equation, V1 minus Vs by R1, V1 minus V reference by R2 plus V1 minus V2 by R3 is equal to 0. So simplifying the equation 1 by taking reference, V reference is equal to 0. Then V1 minus Vs by R1 plus V1 by R2 plus V1 minus V2 by R3 is equal to 0. So by taking V1 and common, then the equation is coefficient wise. We are getting, so V1 by R1 plus V1 by R2 plus V1 by R3 minus V2 by R3 is equal to Vs by R1. So this we can write that. Further, this can be simplified. V1 into 1 by R1 plus 1 by R2 plus 1 by R3 minus V2 by R3 is equal to Vs by R1. So the second equation V2 assume that all currents leaving the node. So here V2 minus KCL at node V2 is, see this equation. Now all the three currents are leaving from V2 and we can write the equation, KCL equation. V2 minus V1 by R3 plus V2 minus V reference by R4 plus V2 minus V reference by R5 plus R6 is equal to 0. So by simplifying this equation, V reference is equal to 0. Then the equation becomes V2 minus V1 by R3 plus V2 by R4 plus V2 by R5 plus R6 is equal to 0. This again we can rearranging this in V2 by R3 plus V2 by R4 plus V2 by R5 plus R6 minus V1 by R3 is equal to 0. So in this we can write further V2 into 1 by R3 plus 1 by R4 plus 1 by R5 plus R6 minus V1 by R3 is equal to 0. So in this way we can write the equation. The two equations, equation 3 and 4 are the nodal voltage equations. So this is the two equations. So V1 into 1 by R1 plus 1 by R2 plus 1 by R3 minus V2 by R3 is equal to Vs by R1. And another equation is V2 into 1 by R3 plus 1 by R4 plus 1 by R5 plus R6 minus V1 by R3 is equal to 0. So this we can write into a matrix form. And the equation again we can, V1 terms should be in the same arrows, same columns. So we can rewrite that minus V1 by R3 plus V2 into 1 by R3 plus 1 by R4 plus 1 by R5 plus R6 is equal to 0. So in the matrix form, the equations are arranged with the coefficients of V1 and V2 as so in this way we can write the equations. See here, the first coefficient V1 coefficient is 1 by R1 plus 1 by R2 plus 1 by R3. And for V2 coefficient is 1 by minus 1 by R3. And in the second equation, the V1 coefficient is minus 1 by R3 and the V2 coefficient is 1 by R3 plus 1 by R4 plus 1 by R5 plus R6 into V1 V2 is the matrix and it equal to Vs by R1 and 0. So in this way we can write the matrix form. See, note down this one. So in this session we discussed about the identifying nodes in the given network, a number of nodes, voltages, voltage equations required to solve a network, writing node voltage equations and arranging them in a matrix form. So a node with 3 or more branches connected, it is called as simple node, principal node. Can you expect? Reference node, super node, this is called principal node. The number of node voltage equations required to solve a given network is n, n plus 1, n minus 1, 2n plus 1. It is the answer. It is n is the principal node, number of principal nodes. N minus 1 is the answer. The node voltage equation is written using KVL, Star delta transformation technique, KCL. Which one is correct? KCL. Explain node analysis with example. So just frequently asked questions in this last class. So differentiate mesh analysis and nodal analysis. Thank you.